So how is the oil recovered? Basically, we want the oil recovering by drilling the oil wells. The oil is always present when there's always gas associated with the oil, and also because of the fissures and fractures in the ground, the water eventually finds its way to the same places that there are oil. Along the way, they dissolve some minerals, so we have a lot of brines. Of course, the gas is lighter than the oil, and the oil is lighter than the brine, so these are stratified, gas on top and oil is in the middle. If you drill a hole and it comes out to basically brine, they don't want all the brine is start gushing out of it. Same is with the gas, it start to gushing out of the oil field, and that causes the oil field pressure to drop. We don't want that to happen, because we want that basically the natural pressure inside this oil field help to force the oil out of the ground. So we usually cap that, and we drill other oil wells until we hit the oil. So the primary method of recovery, or called flush production, is the flow of the oil naturally from the oil well. About 30% of the oil, somewhere around that, naturally comes out without using any basically pump. Then the pressure inside this reservoir drops, so we have to go to the enhanced oil recovery. The next stage is called the secondary recovery. In the secondary recovery, basically we are pumping some stuff and to raise the pressure of the oil. We can pump water through the abundant oil well, we can pump gas, or something that can raise the pressure inside the reservoir again, and causing the oil to flow by itself. So it's more costly, but still it is very doable. Again, another 20-30% of this, depending on the oil field, can be recovered from the secondary method. So how we can recover the rest of it? We have to go to tertiary recovery. Tertiary recovery means to do something with the oil so it can flow easier. Oil is a very viscous substance. It is like a honey. It is very thick and very viscous. They don't flow very easily. So what do you do when you want to flow the honey from the honey jar? Well, the answer is that you either shake it very hard, or most likely you're heating it. By heating it, you're cracking the oil, the heavy molecules into a smaller molecule, and you can cause it that it flows easily. We would say we reduce the viscosity by heating. This is exactly what we do with the tertiary method. We are heating the oil well. The heating can be done by injecting steam into the reservoir, or by maybe blowing up some kind of detonation. In the 1940s, 50s, US tried methods detonating with even nuclear bombs that they detonated on the ground. But then what they found out is that eventually all this oil, they became contaminated with the radioactive material, and so the practice stopped. Now they use it most, the TNT and the conventional method. They detonate it. After detonation, there's a shock wave produced. The shock wave is propagating across the oil field. That's the diagram to the right. And as it moves, then it hits up, the oil, and basically makes very viscous, causing it to flow easier. After oil is recovered, then it has to be refined, depending on what product we want. And how much refining we do. We can find the products that can be used as solvents, as different fuels, as a lubricant, to candle, and the heavier stuff can be used as an asphalt for the roofing and pavement. The third form of fossil fuel in the gaseous form is a natural gas. Natural gas can be found from the only in its form, which is called non-associated gas, or in the fields which is associated with the oil. So that's what the term associated and non-associated gas means. Associated means from the fields which contain oil or petroleum. Non-associated are from the field which only has a dry gas in it. The gas is natural gas is made of what we call it methane, okay, and other hydrocarbons, heavier hydrocarbons. Natural gas can be liquefied into the liquefied natural gas, or the methane of that is being removed. In this case, we have the propane and all the heavier molecules. That's called liquefied petroleum gas, or it can be compressed, to very high pressure, and that's called compressed natural gas. So, like natural gas, it can come in different forms. Petroleum is reliable, is relatively very cheap, environmentally, somewhat, much cheaper than coal and oil. So is environmentally more friendly. It has lower emissions, about 45% less carbon dioxide than coal, 30% less than carbon dioxide than oil. Again, from this diagram, you can see that Russia and Iran and Qatar are the three countries with the most of natural gas in the world. These three countries among themselves, that they're about 43 and about 30, that's 73, that's what 85% of all the, roughly about half of the natural gas. 23%, 16%, 30%, that's what, about half of 50% of the total natural gas belong to these three countries. As we're running of conventional fossil fuel, we have to tap into what we call it unconventional fossil fuel. Unconventional fossil fuels are the ones that they have been formed in the unlikely places that cannot be easily recovered. For example, it can be in the muddy areas, and eventually the mud has been solidified and what that's called the shale gas, or it can be trapped inside the sand, pebbles of sand, and this is called the tar sands. In addition to that, we have a shale gas. That's a gas which is produced from the shales, and these days we have new technologies that we can remove this shale gas, and that has provided quite a bit of a addition to our natural resources. Two technologies which have been very helpful in recovering the shale gas are the horizontal drilling and hydraulic fracturing. Basically, horizontal drilling means that you can drill one well, and after you reach the depths that you want, rather than move it vertically, you can turn the drill bit horizontally, and then you can search the neighboring areas. That prevents it from additional oil well to be drilled, which are very, very expensive. The hydraulic fracturing means that by sending some fluid through these some pipes and fracturing those, or then you can cause the sand to fracture, and that means it releases the natural gas that can flow through the ground and eventually come to the surface. The problem with the conventional fossil fuel is that they are not environmentally very friendly. They have a very, very low yield compared to the other forms of fossil fuel, from 50 to 100 liters per tons of rock, for example, and they're not clean. They can disturb the land, and they can possibly even cause some earthquake. They can make the land unstable, and they can prevent the land to be used for the agricultural and pastoral use.